Today we're going to look at functions. A function expresses the dependence of one measure on another. So if f depends upon x, we write that as f of x. It looks like f parentheses x, but we state it f of x. So in example 1, if we want to write in function notation that the number of bacteria depends on time, then we'll write that function as b of t because bacteria depends upon time. If the grade that I receive depends upon effort, we'll write that function as g of e because grade depends upon effort. If I graph a function and it shows the relationship between two variables, we will have the output on the vertical axis and the input on the horizontal axis. So y equals f of x is a statement that y is a function of x or y depends on x. And if I have that in an equation form, we'll see that the x value is what we think of as the input. We'll put that in the parentheses, which means that it's being input to the function. And what f of x equals is the y value, which is the output for the function. In the graph to the right, we can find function values by thinking of that equation y equals g of x. So I'm going to write this above what we're trying to find. So if the equation is g of x is equal to y, when we look at the expression g of -2, we know that x has been replaced with -2. So we can go to the graph and look at the point where x has been replaced by -2 and observe that the y value is 3. So g of -2 is equal to 3. Similarly, for b, if we think about g of x is equal to y, we know that x has been replaced with 0. So we can go to the graph and look at the point where x is equal to 0 on the graph and observe that the y value is 1. G of 4 is the y value when x is equal to 4. So if we go to the point on the graph where x is equal to 4, we can observe that the y value is 0. For D, if we go to the point on the graph where x is equal to 6, what you'll notice is there is no y value. And so what we can say about g of 6 is that it is undefined. The graph does not tell me a y value, so g of x is undefined. In E, we are asked for what values of x is g of x equal to 2. I'm going to erase what I have on the graph. And again, we want to think of the equation being g of x is equal to y. So if we want to know for what values of x, that means we're looking for x. If g of x is equal to 2, that means that y is equal to 2. So I'm going to look at the places on the graph where y is equal to 2 by drawing a horizontal line. And then I'm going to observe that there are two x values at which this occurs. And those x values are -1 and 3. So we could actually write this as a solution set of 1 and 3. Try the problems below and pause the video, and then you can check your answers. Here are the answers to the try these. Now we've looked at graphs, let's look at a function in equation form. If I want to evaluate a function, that is to find an output for a specific input, I need to replace x with that input value, and so the steps below describe how you would find f of 3 or deal with an input of x equals 3. So in step number 1, you're going to replace x with 3 on both sides of the equation. The result should then be expressed in the form of f of 3 equals the output value after you've done the arithmetic. Bear in mind that f of 3 does not mean f times 3. So, in example 3, we want to figure out what f of negative 3 is. So we're replacing x with negative 3 on the left side of the equation, so it makes sense that we should replace x with negative 3 on the right side of the equation. Now, performing the arithmetic, we should get a result of f of negative 3 is equal to positive 6. In B, we want f of 0. So now we've replaced x with 0 on one side of the equation. I'll write the equation over top. And then replace x with 0. So f of 0 is 0 plus 0, or f of 0 is equal to 0. In C, we're looking for f of 5. So f of 5 is 5 squared plus 5, which is 25 plus 5. So f of 5 is equal to 30. In example 4, we're given that g of x is equal to 3x minus 2. So g of negative 1 can be found by replacing x with negative 1. So I'm going to write g of x right over top of that statement. And then I'm just going to replace the x with negative 1. So g of negative 1 is negative 5. To find g of 2/3, that would be 3 times 2/3 minus 2, or 2 minus 2, or g of 2/3 is equal to 0. For C, we're looking for x, and we have the y value. So it says if g of x is equal to 6. So I'm just going to take my g of x and replace it with 3x minus 2, and then solve for x. Adding 2 to both sides, 3x is equal to 8, and then dividing by 3, x is equal to 8/3. We can find g of w the same way that we find g of any other number, and that is by replacing the x with a w. So g of w is 3w minus 2. And there's nothing else that can be done with that to simplify it. G of a plus 5 is 3 times a plus 5 minus 2. We can simplify that to 3a plus 15 minus 2, or g of a plus 5 is equal to 3a plus 13. Last, this problem's a little bit more challenging. If g of x minus 5 is equal to 3, find x. What we need to do is find out what g of x minus 5 is. G of x minus 5 is 3 times x minus 5 minus 2, and set that equal to 3. Distributing and combining like terms. Adding 17 to both sides. X is equal to 20/3. Pause the video and try the ones below. Here are the answers to the try these. And now a couple more examples. We're going to find several function values and then use those to graph an equation or graph the function. So p of x is equal to negative 2x plus 1. I can just replace x with several values. And then find what the output values are for those input values. So p of negative 2 is negative 2 times negative 2 plus 1, which gives us 5. P of negative 1 is negative 2 times negative 1 plus 1, which is 3. P of 0 is negative 2 times 0 plus 1, which is 1. P of 1 is negative 2 times 1 plus 1, which is negative 1. And P of 2 is negative 2 times 2 plus 1, which is negative 3. This functions like a table of values, where all of the values that are replacing x are our input values, or x values, and all the values on the other side of the equal sign are the output, or the y values. So now I just need to graph all of those ordered pairs: negative 2 comma 5, negative 1 comma 3, 0 comma 1, 1 comma negative 1, and 2 comma negative 3. And you can observe that the graph of p of x is equal to negative 2x plus 1 is a line. We could certainly have graphed that a little bit more easily if we remember the y equals mx plus b form of a line. In B, we'll do a similar thing. What you'll notice about this one, though, is it's a quadratic function. So we'll want to center our values on the vertex. Remember that the vertex occurs when the squared quantity is equal to 0. So that means that we will start with f of 2 as our middle value, and then we can choose 2 points on either side of that x value. So we'll start with inputs of 0, 1, 2, 3, and 4. F of 0 is equal to 4, f of 1 is equal to 1, f of 2 is equal to 0, f of 3 is equal to 1, and f of 4 is equal to 4. And if we graph those points, you have a nice quadratic function in the shape of a parabola for its graph. And that is today's lesson.